Welcome to this screencast which accompanies the Chemistry in Action module, Booklet 1. We'll start by looking at naming organic compounds by looking at the simplest type, hydrocarbons. As the name suggests, hydrocarbons consist only of carbon and hydrogen atoms. Alkanes are the simplest hydrocarbons as they contain only single bonds between the atoms. The names of alkanes end in ane, A-N-E. And the start of the name comes from the number of carbon atoms in the chain, as you can see from the table. You'll need to learn these prefixes. The first few members of the alkane family are shown here. The next two slides contain some exercises on naming and drawing alkanes for you to try. Pause the screencast while you have a go. All of the alkanes we've looked at so far are straight chain alkanes, where all of the carbon atoms in the backbone are in a straight line. However, some alkanes contain branches where other alkyl groups are attached to the main chain. We call these attached groups substituents. When naming branch chain alkanes, there are 3 steps in the method. How many carbon atoms are in the longest chain? Be aware that the longest chain may have been drawn going around a corner. How many carbons are in the substituent or substituents? We name alkane groups slightly differently when they are substituents, replacing the ane with -yl. So an alkane substituent containing 1 carbon atom is a methyl group, and so on. Lastly, we need to specify where the substituent group is attached to the main carbon chain. We do this by numbering the carbon chain from the end which gives the lower number for the position of the substituent group. Let's look at an example. This molecule contains 5 carbon atoms in its longest chain, so its name will be based on pentane. The molecule contains a substituent group containing 1 carbon, which is called a methyl group. The methyl group is attached to carbon 2, counting from the left. If we counted from the right, the position would be numbered as 4, which would be incorrect. Therefore, this molecule is called 2-methyl-pentane. The longest carbon chain in this molecule contains 7 carbon atoms, so its name will be based on heptane. Note how the longest chain hasn't been drawn in a straight line, so remember to check for this. There is a substituent containing 1 carbon atom, so this is a methyl group. The methyl group is attached to carbon 3, counting from the right. Counting from the left would give a position of 5, which would be incorrect. The name of this molecule is 3-methyl-heptane. In molecules where there is more than 1 substituent, they should be listed in alphabetical order, not number order. This molecule has 8 carbon atoms in its longest chain, so its name is based on octane. It has 2 substituent groups, one containing 1 carbon, a methyl group, and one containing 2 carbons, an ethyl group. Counting from the left, the methyl group is on carbon 3, and the ethyl group is on carbon 4. Counting from the right would give positions 5 and 6, which would be incorrect. The name of this molecule is 4-ethyl-3-methyl-octane. Alkenes are hydrocarbons which contain a double carbon-carbon bond. The names of alkenes end in ene, E-N-E. Alkenes are named in a similar way to the compounds we've come across before. The number of carbon atoms in the longest chain forms the basis of the name. Then, the position of the double bond must be specified. Let's look at an example. The molecule shown at the bottom of the slide has 4 carbon atoms in its longest chain, so its name will be based on butene. The double bond is positioned between carbons 2 and 3, so we call this but-2-ene because the double bond starts at carbon 2. The number goes immediately before what it is describing, in this case, the ene. There is another part to naming alkenes, which refers to their cis or trans isomers, but this is covered in a separate screencast, geometric isomers. Alkynes are hydrocarbons which contain a triple carbon-carbon bond. Their names end in -ine, Y-N-E. Alkynes are named in the same way as alkenes, so the number of carbon atoms in the longest chain forms the basis of the name, and the position of the triple bond must be specified. Here are two examples. Both molecules have 4 carbon atoms in their backbone, so are based on butene. The molecule on the left has a triple bond starting at carbon 1, so is but1-ine, and the molecule on the right has the triple bond starting at carbon 2, so is but2-ine. The remaining slides contain the answers to the exercises. More practice questions are available on Unilearn in the Term 2 folder.